Hello everyone, welcome back to IPEC by Sounish. So a few days ago I have uploaded this problem named elliptical mirror from the chapter optics in my channel. So today I have come up with its solution video. So before seeing the solution, I would suggest everyone that attempt this problem 2 to 3 times, then see the solution, because this problem is based on very fundamentals. Some mathematics is involved, but I think all of you can do this. So please attempt this problem, then see this solution. I have given the link of the problem video in the I button. You can check it out from there. So let's see the solution. First of all, intersecting a cone with different planes inclined at different angles and position, we can obtain different curves which are popularly known as conic sections: circle, ellipse, parabola, hyperbola. So all of these curves, which are called conic sections, have got a wonderful reflective property. All of these curves have a wonderful and unique reflective property, and that properties are very much useful in some of the optics problem. So first of all, we will see the reflective property of all of these curves, and then we will jump into our main problem. So as you know, this circle, if any ray, it may be a light ray or sound waves, if they or if they are originating from the center of the circle and reflecting on the surface of this circle, then they are going to reflect back, because at any point on the circle, if you draw a tangent, it will always be perpendicular to the line joining this center and that point. So the property of plane mirrors uh, are used here. So it will reflect back and will go through this center again. So this is the reflective property of circle. Now ellipse, as you know, ellipse has got two foci. Let me name it f1 and f2. So if a light ray originates from one of the foci, then after reflecting from the surface, it will merge into other foci. So this is the reflective property of an ellipse, originating from one focus and it will pass through the another focus. So this is the ellipse property. Now let's see the property of a parabola. So in a parabola, light rays coming parallel to the axis of the parabola will you can say will merge into the focus of the parabola. So this property, I think you have studied in your classes. This property is used in the lights, headlights of car and many other places. And finally, the reflective property of a hyperbola. So if a light rays originating from one of the foci will reflect in such a way that it will seem to be reflected from the other foci. So this is the uh, properties of all these conic sections, and in our problem we will going to use the reflective property of an ellipse. So if you have got any hint, then pause the video and try the problem again. Okay, so In this problem, the first part was you have to find this angle theta for which this light ray gets trapped in this mirror system. So now I can say that if this light ray passes through the foci, one of the foci of this ellipse, then I am sure that it will pass through the another foci. Yes, so suppose this is f1 and this is f2, then if it pass through this focus, then it will again after reflecting from the surface it will pass through this focus. Yes, and again after reflecting it will again pass through this focus. So in this way this light ray gets trapped in this mirror system. So this is the concept part. Now you have to do the calculation, you have to calculate this distance. So I think you all know the basics of ellipse. So this distance is AE. A means the semi-major axis length, that is 5, and E is the eccentricity. Now you have to find the value of E. So I think you all know this formula, B square is equals to A square 1 minus E square. So B square 16, A square 25, so 16 upon 25. So E square is equals to 1 minus 16 over 25, that is 9 over 25. So E is equals to 3 over 5. So AE, that is 5E, this distance is equals to 3. So now you have got this distance is already given. So I think you will be able to find this angle theta. So theta is equals to tan inverse this distance 3 over 8 plus 4 12. So tan inverse 1 over 4. So this is my answer to the first part of the problem. So the problem was very easy, just you have to find this concept part, that you have to use the reflective property of an ellipse. Now in the second part I have asked that you have to find the net distance traveled by this light ray after n reflections. So what will be the net distance? So this distance is already known to me. So it is 12 square plus under root 12 square plus 3 square. So calculate it on your own. Now I think you know this property also, that if you take any point on the ellipse and join it to the focus, then you know this property, pf1 plus pf2 is equals to twice of the length of the semi-major axis, that is 5, so it is 10. So this distance and this distance up to here, this length is twice of the semi-major axis, that is 10. Again this length and up to this length, it is also 10. So as you can see here, that at every reflections, if you start to calculate the distance from here, it travels 10 unit distance at every reflections. So 10 unit, again 10 unit, and it goes like it. So if you have to find the net distance, so the net distance will be this distance whatever it comes, then 10 times. Now if you multiply n, then it may be wrong, because I should have mentioned that this n is very large. So when it is large, you can see here it's almost parallel to this major axis, isn't it? So this is 10, this is 10. So suppose this is the n minus 1th reflection. So this covers 10a distance from here to here. Now before this reflection it will go this distance also. Yes, so you have to calculate this distance also in this net distance. So it will be 10 times n minus 1, 10 times n minus 1. Here it will do nth reflection. So we have to calculate the distance from here to here. That is 2, because it's almost parallel to this major axis, and this length is 3. So this remaining length is 2. So add 2. So this is the answer. Simplify it on your own and you will get the simplified answer. So this is the solution of this problem. So you can use this reflective properties somewhere else also. So remind these properties, and if you have any query, then you can ask me in the comment box. If you have liked this solution video, then hit the like button and share it with your friends who are interested in physics problems. And if you are new to this channel, then make sure that you subscribe to this channel, because I upload problems regularly, and mostly 99% of the problems are created by me, and some of them are taken from somewhere else. So subscribe my channel and keep exploring beyond your vision. I will be back with a new problem again, so stay tuned. Thank you.